Yeah. So welcome to SQL Saturday. This is the first session in the red line room. This is the transaction log and how it affects HADR with Edwin M. Sarmiento. Edwin Edwin is a former MVP and is currently a Microsoft certified master and MCT. He is the managing director of 15C, a consulting company and a training company that specializes in designing SQL Server infrastructures. He's also he's also an author of the book SQL Server DBase Guide to Docker Containers. Is that correct, Edwin?
Yes, I don't know if you can hear me.
There you go. We can hear you.
Perfect. Okay, good.
Yeah.
Okay. Let me know when I'm good to go.
Yeah. So with that, I'll hand it over to Edwin and to start the session.
Sure. Thank you very much. Good morning, everyone. I don't know how this thing would work. Is this going to be like somebody's looking at the Q&A? Are they going to type the questions in the Q&A?
Oh, yeah.
Because I don't see. How's that going to work?
Yeah, good thing that you reminded me. Everyone, the session is currently being recorded. If you have any questions during the presentation, you can drop them off on the chat. It's up to you, Edwin. Do you want me to interrupt you as the questions come, or do you want me to consolidate them at the end so that you can complete your presentation and then just do the Q&A?
Given the amount of time that we have, I think it will be better to leave it at the end of the presentation.
All right. So, folks, if you have any questions, just drop them off on the chat, and then we'll handle it during the Q&A session.
Perfect.
Yep.
Okay. Good morning, everyone. This is a little bit nostalgic for me. I used to be a part of the SQL Server user group in Singapore. In fact, we started it. We were managing it until like 3 of the SQL Server MVPs left Singapore altogether, and then there was none. But this is a very nostalgic thing for me. I was supposed to be in Singapore earlier this year until this whole pandemic thing happened. But I'm really excited about this. I remember having the very first conversation with the people in the community about running the very first SQL Saturday in Singapore. And I'm happy to be here. Let's put it at that. I want to frame our conversation around the topic that we have for this session, very first session. This is all about SQL Server Transaction Log and how it affects high availability and disaster recovery. So it is focused on the SQL Server Transaction Log, but I want you to look at it through the lenses of high availability and disaster recovery. My name is Edwin Sarmiento. Again, if you have any questions, type it in the chat and we'll answer those questions at the end of the session. Hopefully we can cover as much as we can given the limited amount of time. Before I start, I want you to recall a specific incident in the past where you had to solve a specific SQL Server HA or DR problem, where the most stressful incident that happened in the past. And I want you to remember that just for a few seconds. I don't want you to dwell on it because it's going to be very, very depressing. Because I remember exactly how it went when I was still back in operations. And that's why this, for me, is very, very important. Okay? I want to start off by looking at transaction log. We're going to cover mainly the internals of what goes on inside the transaction log. And in order for us to do this, I'm going back to the basics. And for some people, the basics are kind of, it's boring. It's not as exciting as the new features. But the reason this is the most important feature and my favorite feature as far as I'm concerned is because everything in the database engine happens because of the transaction log. And I'll explain in detail as we go along. So how does the transaction log work? Let's say, for instance, you have a SQL Server database, you've got your application, and you're sending transactions to your database. Now, what happens? Let's say you want to run an update statement or an insert or a delete statement, anything that modifies data in a database. What happens is that if the data that you're trying to modify, in this case, the employees table, if the records or the data that you want to modify are not in the buffer cache yet, SQL Server will read the data file, looks for those pages, load them up in the buffer cache, and prepares them for modification. The changes will correspond to transaction log records that will now be written in the log cache. These records in the log cache will then be written into the LDF file. This is called the write-ahead logging and is distinct across all relational database engines. Writing in the transaction log file means those changes have been persisted on disk. During regular checkpoint intervals, SQL Server will then use or write or read those transaction log records that have been committed and then write them onto the data file, whether it's your MDF or NDF file. And this is how it has been ever since SQL Server was created, ever since the beginning. Okay. The log file is accessed sequentially, meaning SQL Server will write to the log file in a sequential write access pattern. It will also read the log file in a sequential file access pattern. Every change that we introduce to the database, whether it's inserting records, updating records, deleting records, DDL statements like create, alter, drop, any change is written in transaction log file. And this allows for point-in-time recoverability. You may be hearing, or you may have heard of the concept of point-in-time recoverability when you have, full recovery model. This is what makes it possible. It also allows for consistency. Remember, I said this is distinct across all relational database engines, and it is the C in the ACID property. The write-ahead logging is what allows the transactions to be written into the log file first. Whatever happens to the system, it is guaranteed to be in the database. It also allows for durability. Again, the D in the ACID property of a relational database is what makes it possible. Now, the log gets full over time. And imagine you create a database, and I'm going to show you this later as we're doing the demo. Imagine creating a new user database with an MDF and an LDF file. The LDF file, or the log, gets full over time. Now, a log file is subdivided into, I call them buckets. These are called virtual log files, or VLFs. Inside the virtual log files are log blocks. These are smaller subdivisions inside the log blocks. I kind of look at the LDF file like a big flat, like those HDB flats in Singapore. And the VLF are those units in the flat. And the log blocks are rooms in those units in an HDB flat. Inside those log blocks are a series of log records. You can think of the log records as the people living in those flats. How does SQL Server track the log records? Remember, initially in the previous slide, we've shown how SQL Server writes every change inside the transaction log file. Now, you may be aware of, user-defined transactions. There are also system-defined transactions. What do I mean by that? You create a table, you insert records. You're familiar with inserting the records as changes to the database. But there's also page allocation, where SQL Server will create data pages and extents. Those are changes within the database that SQL Server keeps track of. And those are also written inside a transaction log. I call them system transactions because it is SQL Server that's generating those transactions. So how does SQL Server track the log records? It uses a thing called the log sequence number. It is the unique identifier of every record in the transaction log. Think of a log sequence number as kind of like a pointer, or let's use SQL Server terms here, like an index in the SQL Server transaction log record. If you want to find a specific record in the table, either you're using a primary key, right, or the clustered index. It's a lot faster to search for the record within a table using an index. And this is what makes the log record unique, the log sequence number. So every single transaction, every log record stored in the log file is kept and kept track using log sequence number. So imagine you got like 4 transactions, and I'm representing these transactions using these color codes. Transaction number 1 is in colored gray. Transaction number 2 is colored red. And because SQL Server writes log records in the log file in a sequential way, you can have simultaneously multiple transactions being written. And again, a multi-user database, you got multiple users reading, writing records in the database. So imagine transaction number 1, these are the records represented by the gray log records. Transaction number 2, these are the transaction log records represented by the red bars or red blocks. Because SQL Server is writing log records in sequence, and because there are so many users introducing these transactions, there's no guarantee that a single transaction and the log records associated with those log records could sit beside each other. Like in this case, you can see that the red transaction log records are, in between the gray ones. Same thing with the blue. The blue log records are in between the yellow and the red. Keep in mind, SQL Server reads and writes transactions in the log file in a sequential manner, meaning if SQL Server needs to keep track of transaction number 2, it will have to look at the red log records in sequence, reading forward if it wants to roll it forward, or reading in reverse if it wants to roll it back. And the log sequence numbers are everywhere. They're in your transaction logs, your backups, your data pages. And the log sequence number is written in a way where it consists of the VLF sequence number, the log block, and the log record number. Now, the first log record written to a VLF makes it active. Regardless of how large or how small the transaction log record size is, it marks the very first VLF as active. And again, you'll see that later in the demo. Now, how many VLFs will be created per log file? Well, there's a formula to it. There's the number and the size. So for instance, if your log file is created with this initial size of 64 meg or an auto growth size of less than 64 meg, it'll be 4 new VLFs at a quarter of the size of the log file. So let's say, for instance, you are creating a new user database and the log file size is 32 meg. Divide that by 4, you got 4 VLFs at 8 meg each. And that includes the auto growth size of the log file, not just an initial file size, but also the auto growth size. If the log file is between 64 meg and 1 gig, it's going to be 1/8 the size of the file. So for instance, you're creating a new database and you have like an 800 meg log file. You'll have 8 VLFs, each one with 100 meg size each, give or take. For anything above 1 gig, you'll have 16 new VLFs at 1/16 the size. So for instance, if you create a new database and you assign the initial size of the log file with 16 gig. You'll have 16 VLFs at 1 gig each. SQL Server 2014 and later made some modifications in the algorithm, and you could actually refer to the blog post from Paul Randall, who runs SQL Skills and used to be a part of Microsoft product team. And the gist of this is you really have to pay attention to the size of the VLFs and the number of VLFs in your virtual log file. In fact, SQL Server 2000, and I think it was SQL Server 2014 and higher, where SQL Server will log in the SQL Server error log if you have more than 10,000 VLFs for a specific database, which is good because now it gives you some understanding or some idea that your database has so many virtual log files, because 10,000 is just way too many. Now, the log gets full over time, right? As you start to write transactions, transaction log records are generated, the log gets full over time. Now, what happens if the log file gets full? Now, every time I ask this question, I get two different answers depending on what their background is. People in the SQL Server DBA camp would say, oh, I know exactly what's going to happen. If the log file gets full, SQL Server will first check for an inactive portion of the log. So let's say the first VLF is marked as inactive. If SQL Server finds a virtual log file that is marked as inactive, it will circle back to write on that portion. This is the circular nature of the log. That's one of the reasons why, if you have a database and simple recovery model, your log file might not grow to a certain size because SQL Server keeps running checkpoints, which truncates the log. And because there are inactive portions of the log, SQL Server can rewrite the log records on those virtual log files. Now, a virtual log file cannot be overwritten until it becomes inactive. So if you look at these, let's say this is one LDF file and I've got like 4 VLFs. The 3 gray VLFs, which are active, cannot be overwritten. Only the first one can be written into. So when does a VLF get marked as inactive? Well, there are a couple of misconceptions out there about when a VLF gets marked as inactive. First is when the records in it at availability groups, for instance, where the log records have to be replicated over to your secondary replicate. If those records have already been replicated and the secondary has sent the acknowledgement message back to the primary that the log records are okay to get truncated, then the VLFs containing those log records can now be marked inactive. And here's the thing, though. Every single log record in that VLF needs to be marked as no longer needed in order for the entire VLF to be marked inactive. It's just like saying, I may have a box full of stuff. All of the stuff in there has to be empty or has to be removed in order for the box to be, marked as empty. Although there's a little bit of misnomer. We keep hearing people say, or DBA say, oh, it's clearing, it's truncating the log. It's actually not true that it is truncating. It's just flipping a switch, ones and zeros, meaning you're either active or inactive. And SQL Server is not overriding the VLFs immediately. It's just going to mark the VLF as, hey, you're inactive, we can truncate it. Okay? What causes the log to get truncated? And I've already mentioned one of the two. The first one, like I said, there are only 2 reasons, and I've only mentioned these 2. or one of these two. The first one is a log backup. If your database is in full or bulk log recovery model, a log backup can, and I'm using the word can here, a log backup can truncate your log file, which means SQL Server will mark inactive the VLFs where the log records in those VLFs are no longer needed. I did say can because there is no guarantee that a log backup would automatically truncate the log. And I've seen a lot of cases where people were wondering, especially in an availability group, because I work with a lot of availability groups, and people are wondering, hey, I'm running my log backups every minute. Used to be every 15 minutes, now every minute. And I've been running it every minute, and the log file doesn't get truncated. There's no guarantee that just because you're running your log backup doesn't mean it will truncate the log. The log records in the VLF need to be marked as no longer needed in order for the entire VLF to be marked as inactive. And I just mentioned an example earlier where if there are log records on those VLFs and those log records in an availability group have not been replicated over to a secondary replica, well, doesn't matter how many log backups you run, it's not going to clear the log. If your database is in simple recovery model, then a checkpoint would clear the log. Let me re-emphasize. Just because you ran a checkpoint doesn't mean it will truncate the log. It's not a guarantee. And that's why we always check for log underscore reuse underscore wait underscore desk. This gives us an idea of what is causing the log to be active. And we'll look at that later in the demo as well. So let's continue. So what happens if the log gets full? Well, if there are no inactive portions of the log, and I'm assuming, being the good DBA you are, you configured auto grow. By default, it is. Although sometimes, I don't know, somebody decided to fix the size of the log file. Don't ever do that. If there are no inactive portions of the log, it will grow. That's where auto growth kicks in. And again, the size of the auto growth determines the number of VLFs on that new auto growth sequence. Okay? It grows and then it grows. Let's have a look at a quick demo on the behavior of the log file to see how it works, unless we have questions at this point. Okay.
No, I think
I'm
you're
going
good to go. There's no questions right now.
Okay. So I'm going to create a new database. I'm going to call it TestDB. And I'm using an example to illustrate what we talked about earlier about the auto growth, about the number of VLFs, about the size of the VLFs. My file growth is set, oops, wrong, zoom it. My file growth is set to 1 meg. My initial size is set to 5 meg. Now, given the size of my LDF and the size of the auto growth increment, you can have a sense of how many VLFs will this database have. That means 4. And the increments during the auto growth will also be 4. The sizes will be different because, initially it's roughly about 1.25 meg upon creation and roughly about 250 plus KB during auto growth increments. And let's have a look at that. Create a database. After creating the database, we'll just set some properties here, just so we minimize the activities inside SQL Server that does not need to go into this demo. I'm going to set it to simple recovery model. That way, the checkpoint process will run under the covers. That way, I don't have to run log backups to truncate the log. Then I'll also set the auto create statistics to off. Again, I'm just simply minimizing the amount of activities happening in the database. Now, here's how to start evaluating the SQL Server log file. The old way was to run the dbcc log info command. And what I'll do is I will run the old way and the new way, which is the systemdb log info DMV. And I'm going to explain some of the contents of these two things, or these two outputs. Let's look at the first one. First column, file ID. By default, that's 2. File ID number 2 is your LDF file. File size. Remember what we talked about earlier? You created your log file with 5 meg size, and using the formula, you divide that by 4, so you get roughly 1.25 something meg. 25, this, same thing as this. Roughly 1.25. Start offset your 8K, and then when you add this to this, you get this size, and you add this to this, you get this size, and so on and so forth. Okay. F sequence number is the VLF sequence number that we talked about. This forms a part of the information in the log sequence number, which we'll look at as well. Status is this. A status of 2 means the virtual log file is active, and every time you create a new database, there will always be one virtual log file marked as active. A status of 0 means it's inactive, and SQL Server added a new status value of 1, I think starting with SQL Server 2017, where 1 is actually initialized but not active. Okay? Parity. The VLF parity. This is switching between 64 and 128, and it's just a marker that SQL Server uses to keep track of, is this the first time I've used this? Is this the second time? And it flips back and forth between 64 and 128. Create LSN is the log sequence number of this virtual log file when it was created. In fact, when you look at all of these are all marked 0s, and this will come into make sense later when we start looking at how SQL Server uses these information. Now let's move forward. Let's introduce some transactions, and in my case, I'm just going to create a table, very wide table, and I'll insert 400 records in the table. Now, currently, all of my VLFs are empty because I don't have anything in there yet, other than the first VLF being marked active. We'll create a table and we'll insert 400 records in those in that particular table. Let's look at this information again and see what happens. And this explains a little bit of what goes on in the transaction log file, as well as what we talked about earlier. We started off with 36 F sequence number, and these were all 0s initially. We started off with 36 because this is the only VLF that was marked active. The rest were all inactive, and that's why they had 0s. We started off with 2 because this is the only one active. The rest are all inactive, and that's why they're all marked as 0s. Same thing, these were all 0s, only the first one was inactive, or the first one was active and the rest were all inactive. But now every single one of the VLFs are all full. Okay. Now here's the thing though. I'm actually talking a little bit slower here because by default, every minute, or depending on how you configured your SQL Server instance to run, checkpoint process occurs under the cover, which means if the checkpoint process occurred, this could have already ran the checkpoint process, or maybe it hasn't. So maybe I should try and run it and look at what happened in the background. And if you see status of 0, which means that the checkpoint process kicked in, truncated or marked the VLFs as inactive, which means I can now start writing back to 36, 37, 38. Okay. Now here's what we can do. Let's introduce some transactions. And this is one of those things where we kind of like the developers because they like to do this. They would create a long running transaction. Okay. Very simple. You just created a long running transaction. And regardless of what's going on, if I run another log info and look at it, it seems like nothing wrong with it, right? Let's add more rows. Let's say I want to insert 400 more rows into it. And this is where we start seeing the circular nature of the log. So we started off with 36, 37, 38, and 39. Only one VLF, which is the last VLF, is marked active. Let's see what happens now. Still nothing fancy. 39, 36, 37, 38, 39 was the last one. Circular nature of the log kicked in. It saw that these three were marked as inactive. Later starts writing into this VLF. That's why you see the parity changed from 64 to 128. Also, F sequence number. It's no longer 36. We start off with 36, 37, 38, 39, circle back to it, 40, 41, 42. I can another checkpoint and see if that will truncate the log. Let's, hasn't truncated the log yet. If we look at log space consumed by the database, it's 82.87% full. It's almost full. Start off with 5 meg, it's almost full because it's 4.92. Okay. Let's see. If I want to run additional or insert additional records in the database, let's see what happens after inserting 400 more records. Very interesting. Let me rerun log info and let's see, the sysdmdb log info DMV side by side. And let's evaluate this. So here's the thing. Circular nature of the log kicked in. We're back to 40, 41, 42, 39. And this is the VLF that contains our long-running transaction. And it's still here. 42, 43, it skipped this VLF over here. Auto growth kicked in and created 1, 2, 3, 4 more VLFs because your auto growth increment is 1 meg. That's why the size is around 250 something K. And if you look at the F sequence numbers from 42, skip this, 43, 44, 45, 46. Let's look at the create LSN value. That's 42. This tells me that these VLFs were created as a side effect of this. They got created because F sequence number 42 is not enough. It needs to create a new virtual log file, and it's keeping track of that. That's why you see that create LSN. But there's more. Started to sound like a infomercial back there. It's not enough for SQL Server to rely on the first 4 VLFs. Auto-growing the log file for an additional 1 meg is not enough. That's why it had to auto-grow for another. It has to kick in another auto growth increment. And that's why you see 1, 2, 3, 4, another 4. But wait, it's not really twice. It actually auto grew 3 times. If you look at this is the first time, this is the second auto growth, and this is the third auto growth. 400 records with 1 megabyte sized increments will have to force SQL Server to auto grow 3 times and create 12 additional VLFs. And that's why the sizing of both your auto growth increments and your initial size is very, very important, because you may end up with so many VLFs within a single file. And keep in mind, we're only dealing with 8 meg at this point. 4, 5, 6, 7, 8. Yeah, 8 meg at this point. And if you look at the DMV, even the size, like 0.24 meg, all of them. And even if, like I said, even if I run a checkpoint, not checkpoint, but checkpoint, even if I run a checkpoint, a manual checkpoint, this is not going to truncate the log. Why? Because we still have this open transaction here. If I rerun this, and if you look at the status column, they're still all active. The only way for me to allow SQL Server to free up and mark those VLFs as inactive is if I either roll forward or roll back this transaction. So let's run a commit trend. By the way, before I do that, I want to run, and I forgot to change the command for this. There's a new DMV to check log space, and right now we're looking at 98% log space use. Huh. So let's commit the transaction, and alongside with this let's also run the checkpoint, just so we'll see the behavior of how SQL Server handles this. If we look at DMV, we now see the VLFs have been marked inactive. And the only VLF that's currently marked active is this one, VLF sequence number 53. And this is a typical question that I get asked all the time. How come if I run a log space or DBCC SQL perf log space, wait a second, 10%, how come I can't shrink the data file, or rather the log file? In fact, when you shrink the log file, it won't object explorer. There we are. Even if I shrink the log file, which I don't recommend doing, but I'm simply saying, hey, I could shrink the log file and force SQL Server to reclaim space, it's not going to go below that size. I want to shrink this, release unused space. And again, I don't recommend that you do this. I'm just using it as an illustration. But if I run SQL perf log space, it's not going to go. Oh, now it did. Let's have a look at that. Now it's back to the original size. And I'm guessing because it's the pointers on the very last one which forced it to roll back. But when you look at the behavior, we've seen the circular nature of the log. You've seen how an active VLF will not force truncation even if you run checkpoints. And this affects availability of your databases. So let's continue. What happens if you can't grow your database? It can get worse because your database will be marked as read-only even if you don't change the database property, okay? And this is where understanding of restore and recovery comes in. Why is this important? Because it supports restoring data from backups whether you're restoring a whole database, a data file, or just a data page from it. Now, the documentation would tell you there are 3 phases of restore, but there are actually 4. What are those phases? The first one, which isn't really documented, is the file creation and initialization. This is when you're restoring from backup. And part of that is it will create the data file and the log file prior to copying the data in the database as part of your restore process. The second is the data copy. This is where SQL Server will start copying the data, the objects from the backup into the database that you're trying to restore. And the 2 that I'm going to focus on for the next couple of slides will be the redo, which is you're rolling forward all transactions in the log record, which is in your backup, whether it's full or log, and rolling them forward to a point that you can recover those data. And the undo, which rolls back any uncommitted transactions and makes the database consistent. Why is this important? Because keep in mind that every transaction that you generate, or every transaction that even SQL Server generates, will have to be written in the SQL Server log file or transaction log file. So say, for instance, that transaction number 1 completes. If checkpoint occurs after the transaction completes, so nothing happens during checkpoint process, those log records will be written onto the database. If a transaction went past the checkpoint, SQL Server will have to roll this forward. If a transaction did not complete and then a system failure occurs, even if those records are already in the LDF file, they will get rolled back for consistency. Same thing with transaction number 4, like transaction number 1, and same thing with transaction number 5. It will be rolled forward. Now, what affects recovery time? Because this is the whole idea behind why we covered the internals of SQL Server Transaction Log file. The number of records in the transaction log impacts your recovery point objective and your recovery time objective. Why? Because more records mean longer restore or recovery time. The more log records, the more that SQL Server has to read those log records and either redo if they're committed or undo if they're rolled back. The size of your transaction log. Only the MDF and the NDF files are affected by instant file initialization. Imagine if you have and I've seen this happen in some of my customers, if you have an 80 gig file size for your log file, how long is it going to take to create the file and zero initialize the log file before the database can be restored, or before the database could be brought online as part of restoring from your backup? The number of VLFs, too many or too few, can both affect your restore performance. Whether you're talking about database mirroring, log shipping, availability groups, replication, backup and restore, too many or too few both affect restore performance. And part of that is also affecting crash recovery, because crash recovery is a combination of both the redo and the undo phase that we talked about earlier. Always keep this in mind when you're looking at high availability strategies. You're looking at it from both an RPO and an RTO point of view, meaning RPO, how many or how much data can you afford to lose? And RTOs, how much time can you afford before we can bring the database back online? How are we doing on time?
10 minutes, 11 minutes to go.
Okay.
Yeah.
So let's look at the different HA and DR solutions. Database mirroring, you're simply sending transaction log records from a principal to a mirror, similar to availability groups. And the only reason I emphasize this is because this was the the foundation behind availability groups. So you're simply sending transaction log records from the principal to the mirror. Oops, from the principal to the mirror. In order for the log records on the principal to be marked as inactive, they have to be persisted and written on the mirror. Even though the redo is always happening, in order for those log records to be marked inactive on the principal, they have to be marked as inactive on the mirror as well. All right. What affects failover time? Well, the amount of log records. The amount of log records in the LDF file will cause the failover time to either go much longer or shorter. And that's why, the good old adage, keep your transactions as short as you possibly can. It's not just for application development and query performance. It's also for high availability and disaster recovery. Again, more records mean longer undo time. Because when you do a failover, SQL Server will only run the undo because the redo process is happening under the covers. What about log shipping? With log shipping, you're doing a backup copy restore of your transaction log. So you're simply, running a log backup, sending the log backup to a folder accessible from the standby, and restoring that log record onto the standby on a regular basis. The sequence of events here, again, it's basically just backup, copy, and restore. But what this means for you is that if you have an existing log backup job, creating a log shipping configuration will break your existing log backup job. So you have to pick and choose. Do you want to use your existing log backup job as the basis for your log shipping, or completely ditch that and just leverage the log shipping configuration and then use the log backups generated as the reference for your log restores? Okay, what affects failover time? Again, the number or amount of log records in the log file, because more records mean longer undo time. And this is also critical because some customers are using the standby for read only. And the read only creates an undo file. If that is, that file becomes large, restoring, if you want to do a failover, will have to redo what's in the undo file. Okay? Failover clustering. What is failover clustering? It's just another high available strategy where you're creating two or more machines and you have a single copy of database. And I'm using a traditional two-node cluster for this. But basically, the idea behind this is when a failover occurs, it's no different from you doing a stop and restart of SQL Server. Although it's on a different machine, but that's exactly what happens. And that is crash recovery, because you're running redo and then you're running undo. The amount of time it takes for you to failover depends, again, on the amount of log records in the LDF file. Again, more log records mean longer failover time, longer recovery time, because you're still running crash recovery in here. What about availability group? Same thing. I kind of look at availability groups as, a merging between failover clustering and database mirroring. So it's an extension of database mirroring. That's why I included database mirroring in the beginning, because that was the foundation of what availability group was built on top of. You got multiple replicas. You got one primary. And then what happens is that you're sending log records from the primary to the different secondary. Now, going back to what I mentioned earlier, if any of the secondary replicas have not reported back to the primary that, hey, those log records have been persisted to disk, then those VLFs cannot be marked inactive, which means regardless of how many log backups you take, it won't truncate the log. And if the log starts growing and it fills up your entire drive, your database will become inaccessible. because there's no more space for SQL Server to start writing those log records. I remember working with a client a couple of years ago where all of a sudden their databases became inaccessible. And this is basically what it was. They killed off one of their secondary for maintenance and not realizing that secondary needs to send acknowledgement messages back to the primary so that the primary can truncate the log. And 2 or 3 days later, databases became inaccessible. Okay. And that's why it's really, really very important for you to look at the transaction log file from the point of view of high availability and disaster recovery. What affects failover time? Again, it's the amount of transaction log records. More records mean longer undo time. And the failover time will take longer if you have more transaction log records to undo in the failover process. And then there's replication. Replication is simply just a data distribution strategy when it was first conceptualized. What happens is that you are not copying log records, but basically you are converting log records into their corresponding logical translation. Meaning, instead of reading the log records, you're converting those log records into corresponding inserts, updates, deletes, or creates. And so it's really not reading the entire log records, but rather only those that were based off of the objects that have to be replicated. So if you only replicate a subset of the database objects, then only those log records will be read and converted into their logical counterparts. So not the entire thing. But again, if those log records in your subscribers have not been fully replicated, those same log records on the publisher won't get marked as inactive. So no amount of log backups can truncate or clear those logs unless those records have been replicated. If there's one thing that I can wrap this whole presentation with, it's this. Transaction log is the most important part of your database. And you could test this out even. You can lose your MDF and NDF file as part of your production database deployment. As long as your LDF files are still alive and accessible, transactions are going to go. All right. You might not be able to read some of the data, especially those that are in the corrupted NDF or MDF file. But if you're simply inserting records, end users won't even notice. That's why it's very important to take care of your transaction log file. I would ask for you to fill up the evaluation forms for this session, and I'm going to open up the floor for questions if you have any.
Yeah, well, thank you, Edwin. That's a very enlightening session. We do have a number of questions on the chat. Let me read them out to you. Daniel Wesley Jones asked, what happens if we have like 4 LDF files with 2 gig each? How much VLF will there be? Does it increase the number of VLF?
Really great question. The formula still applies, although I'm curious as to why you have 4 LDF files, because when you really do think about it, there's no point in having 4 LDF files if SQL Server is only going to read one of them at any given point in time.
Yeah, I think this is a common knee-jerk reaction to some environment. I've seen quite a number of environments with 2 log files just because the first one filled up, they ended up creating another one. Or so, how does it affect the VLF if you have multiple log files?
The VLF is still the same with the formula, because what you're simply doing is you're simply creating a new container for your database log records.
Yeah.
And so the VLF will stay the same. The file size will determine the number of VLFs. The auto growth increments will determine the number of VLFs. But again, I'll use this opportunity to emphasize, it's just like, when you're driving in the highway and you get a flat tire, you fix the flat tire without stopping. This is exactly what it is when you're adding log files, multiple log files. And I completely understand it's a common knee-jerk reaction, but please don't shoot yourself in the foot. Get rid of the other log files, because SQL Server is not going to use them, and it's just going to make your life more I would say miserable if you forget to maintain them properly.
Yeah, that's a problem waiting to happen in case of recovery. Yeah, he does have a follow-up question for high OLT for all TP instances. More VLF gives better performance, or yeah,
Okay, so the question was, is more VLF
better
or
or
less VLF better or worse? Here's how I want you to think of it. If you have 25 items in a box and you have to read all 25 of them, or you have to find one item in a box of 25 items, which one would be a lot faster? Looking for one item in a box with 25 items or one item in a box with 5 items? Of course, it'd be a lot faster for you to find one item in a box of 5 items, which again emphasizes the point. You have to manage the number of VLFs properly. Now, it can't have it too few because you also run the risk of wasting disk space. So let's say you have a 16 gigabyte sized LDF file and you divide that by 16, that's 1 gig. Even if you're using 2K of the virtual log file, it's still marked as inactive, which means SQL Server is not going to be able to truncate that. So you're wasting 1 gig of VLF size just because of that one active log record in the VLF.
Yep. Yep. Yeah, that's good. Another question from Loklu. Although I think you addressed this during the presentation. How does too many VLF impact, or too many or too few VLF impact the performance of recovery?
And like I said in just the response to the previous question, again, it's just like trying to find one item in a box of 25 items or one item in a box of 5 items. SQL Server, when you restore from backup or when you run crash recovery, SQL Server will have to read every single one of those log records in order to properly redo or undo. Now, if you have too many VLFs, SQL Server will have to look at every single one of them, and every single one of them will also have a pointer to the before and the after log record. So too many things to read means it will take longer to do a recovery or a failover or a crash recovery or a redo or an undo.
Yeah. Yeah, and keep in mind, whenever you start your instance, you're basically doing a recovery for the database. So
exactly,
also affects your startup. So before we go to the other 2 questions, I just want to remind everyone that to fill up the evaluation form, the link is also in the chat. If you want, if you fail to do the scan when Edwin showed it, yeah, there it is. There it is on the screen. There's another question from Malikarjun. What is the most often reason for AG latency in synchronous commit mode?
That is a question that requires more than enough information to be answered in a 30-second response. So you could, send me an email. We'll respond because that, again, it's not a yes or no answer. It requires a lot of investigation for that.
There's a lot of things involved, and it depends on what you're seeing in your environment. Yeah, and Bonsi have a question. Let me just make sure I got this. We have a client database that has a log reuse wait desk for log backup. Indicates very low insert delete insert activity. Insert update activity. My way to force log reuse wait description to nothing is to simulate activity by inserting dummy data to a dummy table, which works. Would a better use of my time be rather to wait for it to clear to nothing, given its low activity?
Here's my question to you. How critical is what you're doing to the database? Because if it's not, you can either automate that or just forget about it. Yep. Because we DBAs are so focused on, let me try to fix this. If the problem doesn't really affect the availability and criticality of the database, I'll just let it be. And I know that's not the answer you want to hear from somebody, but let me tell you this. The more you focus on the problems that really matter to the business, the more you can grow your career.
Good point. Or maybe just address the the issue itself, because it's saying log backup. Why not schedule a log backup for that database?
Exactly.
Yeah. Yeah. So I guess we got all the questions on the chat. So thank you very much, Edwin, for your session. Oh, oh yeah, that's the last one. I thought something popped out again. So to the attendees, make sure you fill up the evaluation form. That's also gonna be the entry for the raffle, and we'll gonna email the winner and announce it later. With that, thank you very much, Edwin. Thank you for coming here and sharing again with the SQL Saturday with the Singapore SQL Pass.
And thank you so very much. Again, this is for me one of the best things that I've done this year because I've always wanted to go back to Singapore. This is kind of like almost going back to Singapore. Enjoy the rest of your day, everybody.
All right.